Hello, in this lecture we will find out the radius of the circle. In the drawing we have quadrilateral ABCD. In the drawing we have quadrilateral ABCD, and quadrilateral ABCD is inscribed by this circle. We know that AB, side AB of quadrilateral ABCD equals to 3 units, so we will define side AB as A, and A equals to 3 units. And we also know that side BC of quadrilateral ABCD equals to 4 units. So we will define side BC as B, and we know that B equals to 4 units. And we also know that side CD of quadrilateral ABCD equals to 5 units. So therefore we will define side CT as C. So C will be equal to 5 units according to what is given us the question. And we will define, we also know that side AD of quadrilateral ABCD equals to 6 units, so we will define side AD as D, and we know that D equals to 6 units. Okay, so in the next step I will present to you 3 rules, and we will implement those 3 rules in our drawing, in our quadrilateral that it is inscribed by this circle. Okay, so rule number 1 states that the area of a quadrilateral that inscribed, that it is inscribed by circle equals to the root of S minus A, S minus B, S minus C, S minus D. So suppose that we have quadrilateral ABCD. This is the sign of the area of quadrilateral ABCD. It will be equal to the root of S times A times S times B times S times C times S times D. S equals to the sum of its sides, or the length of its 4 sides, A plus B plus C plus D over 2. So we draw the quadrilateral that is inscribed in this circle, this will be quadrilateral ABCD, and the area of quadrilateral ABCD, actually we have here the original drawing. If we have a quadrilateral that it is inscribed in a circle, then the area of this quadrilateral will be equal to the root of s minus a times s minus b times s minus c times s minus d. Okay, so this quadrilateral ABCD is inscribed in the red circle. We will define the size of side AB of quadrilateral ABCD as A, that is to say AB equals to A units. BC will be defined as B, that is to say BC equals to B units. CD will be defined as C, that is to say CD equals to C units. And AD equals to D, that is to say AD equals to D units in its size. And according to rule number 1, if we have a quadrilateral like this quadrilateral that is inscribed in a circle, like in this drawing, quadrilateral ABCD is inscribed in this red circle, then the area of this quadrilateral ABCD, the area of quadrilateral ABCD equals to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of this quadrilateral sides, and s equals to a plus b plus c plus d over 2. Okay, so if you have a quadrilateral that is inscribed in a circle, or that is inscribed by a circle, then the area of a quadrilateral that is inscribed in a circle will be equal to this expression, when s equals to the sum of its 4 sides over 2. Okay, I will repeat again on rule number 1. Rule number 1 states that the area of a quadrilateral that it is inscribed by a circle, like this quadrilateral ABCD is inscribed by this red circle, the area equals to the root of s minus a times s minus b times s minus c times s minus d, when a, b, c, and d are the lengths of the quadrilateral sides, and s equals to the sum of the quadrilateral sides over 2. That is to say, it equals to a plus b plus c plus d over 2. Okay, so if you have a quadrilateral that is inscribed by a circle, then you can all use this formula in order to find out the area of that quadrilateral. Okay, this is rule number 1, and we also have rule number 2. Rule number 2 states that if a quadrilateral is inscribed by a circle, Then the product of its diagonals equals to the sum of the product, to the sum of the products of its opposite sides. I will repeat rule number two again. Rule number two states that if a quadrilateral is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number two? The meaning of rule number two is that if you have a quadrilateral that is inscribed by this circle, so we have quadrilateral ABCD. Quadrilateral ABCD is inscribed by the red circle. So whenever you have a quadrilateral that is inscribed by a circle, like in this drawing, quadrilateral ABCD is inscribed by this red circle, and we know that side AB of quadrilateral ABCD equals to A units, that is to say AB equals to A units, BC will be defined as B, that is to say BC equals to B units in its size, CD will be defined as C, that is to say side CD of quadrilateral ABCD will be equal to C units in its size, and side AD will be defined as D, that is to say side AD equals to D units in its size. Okay, and we also have two diagonals inside this quadrilateral ABCD. The first diagonal is diagonal BD, and the size of diagonal BD will be defined as X, that is to say BD equals to X units in its size. And we will also draw the second diagonal, diagonal AC, and the diagonal AC will be defined as Y, that is to say AC equals to Y units in its size. Then according to rule number two, the product of its diagonals, of a quadrilateral that it is inscribed by a circle, that is to say it is the product of these diagonals is of this quadrilateral ABCD equals to X times Y. The product of quadrilateral ABCD diagonals equals to X times Y, and according to rule number two, the product of a quadrilateral, the product of the diagonals of a quadrilateral that is inscribed by a circle, like in this drawing, equals to the sum of products of its opposite sides. As you can see from the drawing, quadrilateral ABCD has two pairs of opposite sides. The first pair of opposite sides are AB and CD. Side AB is the opposite to side CD, and we know that the size of side AB is A units and the size of CD is C units. So according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of product of its opposite sides. So the product of its opposite sides, here we have A times C. This is the first product of the first pair of opposite sides, and the second pair of opposite sides are side BC is opposite to side AD. We know that side BC equals to B units in its size and side AD equals to D units in its size. And the product of those two opposite sides equals to B times D. And according to rule number 2, the product of its diagonals equals to the sum of the products of its opposite sides. So the first product of its opposite sides is A times C, and the second product of its opposite sides is B times D, and the sum of the product of its opposite sides is actually AC plus BD, and AC plus BD is the sum of the products of its opposite sides, and the sum of the product of its opposite sides equals to the product of its diagonals. The product of its diagonals is x times y. The product of its diagonals equals to the sum of the products of its opposite sides, and the sum of the products of its opposite sides is AC plus BD. So the product of its diagonals is x times y, and this product equals to the sum of the products of its opposite sides, that is to say it equals to AC plus BD. Okay, so whenever you have a quadrilateral that is inscribed by a circle, like in this drawing, quadrilateral ABCD is inscribed by this red circle, then the product of quadrilateral ABC diagonals is x times y, and this product equals to the sum of the products of its opposite sides, and the sum of the product of its opposite sides is AC plus BD. The first product is A times C, the second product is B times D, and the sum of the product of its opposite sides is AC plus BD, and that equals to the products of its diagonals, that is to say it equals to x times y. So xy equals to AC plus BD. If you have a quadrilateral that is inscribed by a circle, then x times y, that is the product of its diagonals, equals to the sum of the products of its opposite sides. It equals to AC plus BD. Okay, so if a quadrilateral is inscribed by a circle, like this quadrilateral ABCD is inscribed by this circle, then the product of its diagonals, is x times y. X times y equals to the sum of the product of its opposite sides, and the sum of the products of its opposite sides is AC plus BD. So the product of its diagonals is x times y, and that product equals to the sum of the products of its opposite sides, that is to say it equals to AC plus BD. So that is rule number 2. And we also have rule number 3. Rule number 3 states that if a triangle is inscribed by a circle, then the radius of that circle equals to the product of that triangle's sides over 4 times the area of that triangle that is inscribed by the circle. I will read all number 3 again. All number 3 states that if a triangle is inscribed by a circle, then the radius of that circle equals to the product of that triangle sides. It equals to the product of that triangle sides over 4 times the area of that triangle. So what is the meaning of rule number 3? The meaning of rule number 3 is that if you have a triangle that is inscribed in a circle, like triangle ABC, triangle ABC, so this triangle, triangle ABC, and we also know that side AB of triangle ABC equals to A units in its size, side BC of triangle ABC equals to B units in its size, and side AC of triangle ABC equals to C units in its size. So we have here a triangle that is inscribed by the red circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangles ABC sides. The product of triangle ABC sides is actually A times B times C over 4 times the area of triangle ABC. Okay? Again, I'll repeat on rule number 3 again. According to rule number 3, if you have a triangle that is inscribed by a circle, like in this drawing, triangle ABC is inscribed by this red circle, then the radius of this red circle will be equal to the product of the triangle sides. That is to say, it will be equal to A times B times C over 4 times the area of this triangle, triangle ABC. Over 4 times of the area of triangle ABC. Okay? Again, if a triangle is inscribed by a circle, like in this drawing, triangle ABC is inscribed by this circle, then the radius of this that circle, the radius of this red circle that blocks triangle ABC will be equal to the product of that triangle sides to the product of triangle ABC sides, that is to say A times B times C, over 4 times the area of this triangle, over 4 times the area of triangle ABC. Okay, so that is rule number 3. So we actually will implement all 3 rules that I presented to you in our drawing. So according to rule number 1, the area of this quadrilateral ABCD equals to the area of quadrilateral ABCD. This is the sign of area of triangle ABCD, equals to the root of S minus A times S minus B times S minus C times S minus D. When A, B, C, and D are the sides, the length of the sides of quadrilateral ABCD, for example, side AB equals to A units in its size, side BC equals to B units in its size, side CD equals to C units in its size, and side AD equals to D units in its size. In our example, we know that D equals to 6 units, but in general, it can be also, it is true for any other quadrilateral that is inscribed inside a circle. So the area of this quadrilateral ABCD will be equal to the root of S minus A times S minus B times S minus C times S minus D. So ABCD are the lengths of the quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. Okay? We will implement also rule number 2. According to rule number 2, we have here quadrilateral ABCD. It is inscribed by this blue circle. Quadrilateral ABCD has 2 diagonals. The first diagonal is diagonal BD. We define the size of diagonal BD as X units, that is to say BD equals to X units in its size. And we have also the second diagonal AC, and the diagonal AC will be defined as Y, that is to say the size of line segment AC equals to Y units. And according to rule number 2, the product of its size, the product of its diagonals, the product of a diagonal that is the product of the quadrilateral ABC. If a quadrilateral ABCD is inscribed in a circle, like in our drawing, then the product of its diagonals, that is to say X times Y, equals to the sum of the products of its opposite sides. The first product of the opposite sides is AC, and the second product of the opposite sides is BD, and it actually equals to the sum of the products of its opposite sides, that is to say it equals to AC plus BD. Again, according to rule number 2, the product of its diagonals, that is to say x times y, equals to the sum of the products of its opposite sides, that is to say it equals to AC plus BD. So that is the implementation of rule number 2 in our specific drawing. xy equals to AC plus BD, and we will implement rule number 3 in our drawing. We will focus on triangle ABC. This triangle, if we focus on triangle ABC, we can see that triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times Y over 4 times the area of triangle ABC. Okay? Again, according to rule number 3, if we focus on triangle ABC, triangle ABC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks triangle ABC will be equal to the product of triangle ABC sides, that is to say it will be equal to A times B times Y over 4 times the area of triangle ABC. That is the implementation of rule number 3 in our drawing if we relate to triangle ABC that is inscribed by the blue circle. So here we will multiply equation number 3 by the area of triangle ABC, and we will get that R times the area of triangle ABC equals to ABY over 4. So we multiplied equation number 3 by the area of triangle ABC, and we got this expression. We will divide equation number 3 by R, and we will get the area of triangle ABC. We will get that the area of triangle ABC equals to, according to equation number 3, equals to ABY over 4R. Okay, we found out the area of triangle ABC. Okay, we found out the area of this triangle ABC. In the next step, we will focus on triangle ADC. Okay, triangle ADC is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this circle that blocks this triangle ADC will be equal to the product of triangle ADC sides, that is to say it will be equal to C times D times Y over 4 times the area of triangle ADC. I will repeat again, we implemented rule number 3 in our drawing when we focused on triangle ADC that is inscribed by this blue circle. Therefore, according to rule number 3, the radius of the circle that blocks triangle ADC will be equal to the product of triangle ADC sides. That is to say, it will be equal to C times D times Y over 4 times the area of triangle ADC. Okay, here we will multiply equation number 4 by the area of triangle ADC, and we will get that R times the area of triangle ADC equals to C dy over 4. Here we will divide equation number 4 by R, and we will get the area of triangle ADC. So we found out that the area of triangle ADC equals to C dy over 4R. Okay, we found out the areas of triangle ADC and the area of triangle ABC. Okay, but as you can see from the drawing, triangle quadrilateral ABCD consists of those two triangles, triangle ABC and triangle ADC. As you can see from the drawing, quadrilateral ABCD consists of exactly those two triangles, triangle ABC and triangle ADC. Therefore, the area of the area of quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. So I will write it down. The area of quadrilateral ABCD, this quadrilateral, will be equal to the area of triangle ABC, this triangle, plus the area of triangle ADC, this triangle. I will repeat again. The area of quadrilateral ABCD will be equal to the area of triangle ABC, and the area of triangle ADC, because it consists of, quadrilateral ABCD consists of exactly those two triangles. Therefore, the area of triangle quadrilateral ABCD will be equal to the area of triangle ABC plus the area of triangle ADC. But we have already found out the area of triangle ABC and the area of triangle ADC, so we substitute those two expressions by the areas of triangle ABC and the area of triangle ADC. Okay, and we will get that the area of quadrilateral ABCD equals to the area of triangle ABC, that is actually ABY over 4R, plus the area of triangle ADC. We have already found out that the area of triangle ADC equals to CDY over 4R. So here we will take out a common factor y over 4R out of these expressions, and we will get that the area of quadrilateral ABCD, according to the first equation, will be equal to, so y over 4R will be taken out as a common factor of these two expressions, and what is left inside the brackets? Inside the brackets is left here only AB, and here is left only CD. So we found out that the area of quadrilateral ABCD equals to y over 4R times AB plus CD. Okay? So in the next step we focus on triangle BDC. Okay? We focus on triangle BDC. As you can see from the drawing, triangle BDC, this triangle is inscribed by the blue circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X, over 4 times the area of triangle BDC. I will repeat again. Because of the fact that triangle BDC is inscribed by this blue circle, we can implement rule number 3 on triangle BDC that is inscribed by this blue circle. According to rule number 3, the radius of this blue circle that blocks triangle BDC will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X. It will be equal to B times C times X over 4 times the area of triangle BDC. We will multiply equation number 5 by the area of triangle BDC, and we will get that 5 times the area R times the area of triangle BDC equals to BCX over 4. We will divide equation number 5 by R, and we will get that the area of triangle BDC equals to BCX over 4R. We found out that the area of triangle BDC equals to BCX over 4R. Okay? So, in the next step, we will focus on the triangle ABD. This triangle ABD. As you can see from the drawing, this triangle ABD is inscribed by this blue circle. Therefore, according to rule number 3, the radius of this blue circle will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times X over 4 times the area of triangle ABD. So, I will repeat again. We implemented rule number 3 on triangle ABD that is blocked by this blue circle, according to rule number 3, because of the fact that triangle ABD is blocked by this blue circle, then the radius of this blue circle will be equal to the product of triangle ABD sides, that is to say it will be equal to A times D times X over 4 times the area of triangle ABD. Okay, we'll multiply equation number 6 by the area of triangle ABD, and we will get that R times the area of triangle ABD equals to ADX over 4. Here we will divide equation number 6 by R, and we will get the area of triangle ABD. we will get that the area of triangle ABD equals to ADX over 4R. We found out that the area of triangle ABD equals to ADX over 4R, and we have already found out that the area of triangle BDC equals to BCX over 4R. Okay? But as you can see from the drawing, quadrilateral ABCD consists of those two triangles, triangle BDC and triangle ABD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. It is very simple, you can see it from the drawing. If you combine triangle ABDC with triangle ABD, we'll get the quadrilateral ABD, the quadrilateral ABCD. Therefore, the area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD. So I will write it down. So the area of quadrilateral ABCD, according to the second equation, will be equal to the area of triangle BDC plus the area of this triangle ABD. I will repeat again. The area of quadrilateral ABCD will be equal to the area of triangle BDC plus the area of triangle ABD, because of the fact that triangle quadrilateral ABCD consists of those two triangles, exactly those two triangles. Okay, but we already know what is the area of triangle BDC and what is the area of triangle ABD. So we'll substitute the area of triangle BDC by the value that we found for it, and we will substitute the area of triangle ABD by the value that we found for the area of triangle ABD. Okay, so we'll do it now. We'll get that the area of quadrilateral ABCD equals to the area of triangle BDC. That is actually, we have already found out that it equals to BCX over 4R, and we have already found out that the area of triangle ABD equals to ADX over 4R. So here we'll take a common factor of x over 4R out of this expression and and we will get that the area of quadrilateral ABCD, according to the second equation, equals to, so we will take x over 4R as a common factor of those two expressions. We'll take them out, and inside the brackets what is left is actually BC, and here what is left inside the brackets after we took x over 4R as a common factor, after we took out x over 4R as a common factor, what is left is AD. So in total we got that the area of quadrilateral ABCD, according to the second equation, equals to x over R times BC plus AD. But we have already found out that the area of quadrilateral ABCD, according to the first equation, equals to y over 4R times AB plus CD. So we have two different expressions for the area of quadrilateral ABCD. We will actually multiply equation number 1 by equation number 2. We will get equation number 3. That is actually the area of quadrilateral ABCD squared. And it will be equal to xy over 4r squared BC plus AD times AB plus CD. Okay, we take a root out of this equation number 3, and we will get that the area of quadrilateral ABCD, according to equation number 3, will be equal to the root of the expression in the numerator. That is to say, it will be equal to the root of xy. In the brackets we have BC plus AD, and we have the second brackets of AB plus CD, all inside the root. Okay, it will be equal to the root of this expression. This is what happens in the numerator, and in the denominator we took out the root of this equation number 3, so the root of 4r squared equals to 4r because of the fact that the square is cancelled by the root. So what is left is 4r. So we actually found out that the area of quadrilateral ABCD equals to these expressions. So here we will multiply equation number 3 by r, and then we will divide it by the area of quadrilateral ABCD in order to get the radius of the circle. That is the actually that is the thing that we are looking for in this question, the area of the circle, that is capital R. So first of all, we will multiply equation number 3 by capital R, and then we will divide it by the area of triangle of quadrilateral ABCD. We get that R times the area of quadrilateral ABCD equals to the root of xy times BC plus AD times AB plus CD over 4. Okay, we multiplied equation number 3 by r. Here we will divide, and we got this expression, and here we will divide equation number 3 by the area of quadrilateral ABCD, and we will get the radius of the circle. Okay, we will get that the radius of the circle R, capital R, equals to the root of xy times BC plus AD and AB plus CD over 4 times the area of quadrilateral ABCD. Okay, so we divided equation number 3, this equation, by the area of quadrilateral ABCD, and we got the radius of the circle. So here we have inside the root x times y, and according to rule number 2, x times y, that is the product of the diagonals of quadrilateral ABCD equals to AC plus BD. This is according to rule number 2, XY equals to AC plus BD. According to rule number 2, we've already did it. So we'll substitute XY in equation number 3 by AC plus BD that equals to XY. And we will get that the radius of the circle equals to the root of XY will be substituted by AC plus BD. We'll multiply AC plus BD by BC plus AD. And we'll also multiply it by AB plus CD, all divided by 4 times the area of quadrilateral ABCD. We actually have calculated the area of quadrilateral ABCD according to rule number 1. I will repeat on it. We will calculate again the area of quadrilateral ABCD according to rule number 1. According to rule number 1, the area of quadrilateral ABCD is quadrilateral. According to rule number 1 equals to the root of S minus A times S minus B times S minus C times S minus D. And we know that C equals to A plus B plus C plus D. S equals to A plus B plus C plus D over 2. That is to say, I will write down that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. Then we will find out that S equals to 3 plus 4 plus 5 plus 6 over 2. 3 plus 4 is 7, 7 plus 5 is 12, 12 plus 6 is 18, and 18 over 2 is 9. So we found out that S equals to 9, so we can substitute S by 9 in this equality, and we will get that the area of quadrilateral ABCD equals to the root of S is 9, A is 3, so S minus A is 9 minus 3, then S minus B is 9 minus 4, then S minus C is 9 minus 5, then S minus D is 9 minus 6. So in total we will get that the area of quadrilateral ABCD equals to the root of 9 minus 3 is 6, 9 minus 5, 9 minus 4 is 5, 9 minus 5 is 4, and 9 minus 3 is 3. 9 minus 6 is 3. 9 minus 6 is 3. So in total we got that the area of quadrilateral ABCD equals to the root of 6 times 5 is 30, 30 times 4 is 120, and 120 times 3 is 360. So we found out that the area of quadrilateral ABCD equals to the root of 300 square units. So we can substitute the area of quadrilateral ABCD in equation number 3 by the root of 360 square units. So we will do it now, and we will get that the radius of the circle equals to R equals to the root of AC plus BD. AC plus BD times BC plus AD times AB plus CD over 360. And actually all divided by 4, so we got that the radius of the circle equals to this expression. We substituted the area of quadrilateral ABCD here by the root of 360 that we found out, and we have these variables A, B, C, and D are all known, so the only thing that is left to do is to put the data inside this equation, and we will find out the area of the radius of the circle that blocks quadrilateral ABCD. We know that A equals to 3 units, B equals to 4 units, C equals to 5 units, and D equals to 6 units. So we will put this data inside this equation number 3, and we will get that the radius of the circle equals to 1 over 4 times the root of A is 3, C is 5, 3 times 5 is 15, plus B is 4, D is 6, 4 times 6 is 24, times BC. B is 4, C is 5, 4 times 5 is 20, plus AD. A is 3, D is 6, 3 times 6 is 18, and AB. A is 3, B is 4, 3 times 4 is 18, is 20, is 12, 4 times 3 is 12, plus CD. C is 5, D is 6, 5 times 6 is 30, all divided by 360. So R equals to the root of the root of 15 plus 24 is 39, times 20 plus 18 is 38, and 20 plus 30 is 42, all divided by 360, all multiplied by 1 over 4. So the radius of the circle equals to all this expression inside the root is actually 172.9, all divided by 4. So we actually found out that the radius of the circle R, capital R, equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of the circle equals to 3.287 units. Okay, so we have two different ways to present the answer. The radius of this circle equals to either the root of 172.9 0.9 over 4 is equals to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this circle. Inside this circle, we have quadrilateral ABCD that's inscribed in this circle, and we know that side AB equals to 3 units. We defined side AB as A, and A equals to 3 units. Side BC equals to 4 units, so we defined side BC as B, and B equals to 4 units. And we also know that CD equals to 5 units, so we defined side CD as C, and C equals to 5 units. And we also know that AD equals to 6 units, so we defined AD, side AD as D, and D equals to 6 units. And we want to find out the radius of this circle that blocks quadrilateral ABCD. Okay, so in order to find out the radius of this circle, I presented to you 3 rules. Okay, actually, rule number 1 was that the area of a quadrilateral that it is inscribed by a circle equals to, suppose that we are talking about this quadrilateral ABCD and its sides AB equals to 8 units, BC equals to B units, CD equals to C units in its size, and side AD equals to D units in its size. Okay, so the area of quadrilateral ABCD, that could be any quadrilateral that is inscribed by a circle, equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides, and S equals to A plus B plus C plus D over 2. So it is the sum of quadrilateral ABCD sides over 2. Okay, so whenever you have a quadrilateral that is inscribed in a circle, like in this drawing, then you can calculate the area of this quadrilateral by using this formula. So the area of quadrilateral ABC equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of quadrilateral ABC sides, as you can see in this drawing, and S equals to the sum of its sides, that is to say AB plus B plus C plus D over 2. Okay? And we also have rule number 2. Rule number 2 is that if a quadrilateral is inscribed by a circle, then the product of its diagonals equals to the sum of the products of its opposite sides. So what is the meaning of rule number 2? Rule number 2 means that if you have, first of all, it is a quadrilateral that is inscribed in a circle, or quadrilateral that is inscribed by a circle, then we have 2 diagonals inside this quadrilateral ABCD, diagonal BD, and the size of diagonal BD is X units, and diagonal AC equals to Y units in its size, that is to say AC equals to y units and BD equals to x units in its size. So according to rule number 2, the product of the diagonals, that is to say x times y, equals to the sum of the products of its opposite sides. We have here two pairs of opposite sides. Side BC is opposite to side AB, and the product of those two opposite sides is B times D. And the second pair of opposite sides are side AB, it is opposite to side DC, and the product of those two opposite sides is A times C. So we have two products of the opposite sides, and the sum of the product of the two opposite sides is AC plus BD. And the sum of the product of the opposite sides, it equals to the products of its diagonals. That is to say, it equals to x times y, or the products of quadrilateral ABCD diagonals is x times y, and this product equals to the sum of the products of its opposite sides. That is to say, it equals to AC plus BD. So whenever you have a quadrilateral that is inscribed by a circle, then the product of the quadrilateral diagonals, that is x times y, will be equal to the sum of the products of its opposite sides. That is to say, it will be equal to AC plus BD. Okay? So it is apply only on quadrilaterals that are inscribed by a circle, and only on them, not on any other quadrilaterals. On a cyclic quadrilateral, a quadrilateral that can be inscribed by a circle. Okay, any quadrilateral that can be inscribed by a circle, the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. That is to say, it will be equal to AC plus BD. Okay? So any diagonal, any quadrilateral that is inscribed by a circle, the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. That is to say, it will be equal to AC plus BD. So x times y, the products of its diagonals, will be equal to the products of its opposite sides. That is to say, it will be equal to AC plus BD. Okay? That is rule number 2. If a triangle is inscribed by a circle, then the radius, if a triangle is inscribed by a circle, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides, will be equal to AC plus BD. Okay, so xy, the product of the quadrilateral diagonals, will be equal to the sum of the products of its opposite sides. That is to say, it will be equal to AC plus BD. Okay, that is rule number 2, and we also have rule number 3. According to rule number 3, if a triangle is inscribed by a circle, then the radius of that circle equals to the product of that triangle sides over 4 times the area of that triangle. So according to rule number 3, if we have a triangle like this triangle ABC, that is inscribed inside the circle, triangle ABC is inscribed by the red circle, then according to rule number 3, the radius of this red circle will be equal to the product of triangles ABC sides, that is to say, it will be equal to A times B times C over 4 times the area of triangle ABC. So the radius of a triangle that blocks, the radius of a circle that blocks a triangle like in this drawing will be equal to the product of the triangle's sides that is blocked by this circle. That is to say, here it will be equal to A times B times C over 4 times the area of the triangle that is blocked by the circle over 4 times the area of triangle ABC in this drawing. So R, the radius of the circle, equals to A times B times C. That is the product of the triangle's sides over 4 times the area of this triangle that is blocked by the circle. That is to say, it will be equal to 4 times the area of this triangle, triangle ABC. So R equals to ABC over 4 times the area. R equals to ABC over 4 times the area of triangle ABC. Okay, that is all rule number 3. And we implemented all 3 rules in our drawing. According to rule number 1, the area of this quadrilateral ABCD equals to the root of S minus A times S minus B times S minus C times S minus D, when A, B, C, and D are the lengths of these quadrilateral sides, and S equals to A plus B plus C plus D over 2. That is rule number 1. And according to rule number 2, if you have a quadrilateral that is inscribed by a circle, then the product of its diagonals, that is to say x times y, will be equal to the sum of the products of its opposite sides. That is to say, x times y will be equal to AC plus BD. Okay, x times y will be equal to AC plus BD. And we have also rule number 3. We will implement rule number 3 on triangle ABC that is blocked by this blue circle. And according to rule number 3, the radius of that circle that blocks triangle ABC will be equal to the product of triangle ABC sides. That is to say, it will be equal to A times B times Y over 4 times the area of triangle ABC that is blocked by this circle. So the radius of the circle that blocks triangle ABC will be equal to the product of the triangle's sides. That is to say, it will be equal to A times B times Y over 4 times the area of that triangle that is blocked by this circle. Over in our drawing, it will be equal to 4 times the area of this triangle, triangle ABC. Okay, so R equals to ABY, that is the product of triangle ABC sides over 4 times the area of triangle ABC. Okay, then we actually multiplied equation number 3 by the area of triangle ABC, and we got that R times the area of triangle ABC equals to ABY over 4. We divided equation number 3 by R, and we got that the area of triangle ABC equals to ABY over 4R. Then we focused on triangle ADC. Triangle ADC is blocked or is inscribed by this circle. Therefore, according to rule number 3, the radius of this blue circle that blocks triangle ADC will be equal to the product of the triangle sides. That is to say, it will be equal to C times D times Y over 4 times the area of triangle ADC. This is according to rule number 3. Here we multiplied the area, equation number 4, by the area of triangle ADC. We got this equation. Then we divided equation number 4 by R, and we got that the area of triangle ADC equals to CDY over 4R. So we actually found out the areas of triangle ABC and the area of triangle ADC. But as you can see from the drawing, the area of triangle ABC plus the area of triangle ADC equals to the area of quadrilateral ABCD. Again, the area of quadrilateral ABC equals to the area of triangle ABC plus the area of triangle ADC, because of the fact that triangle quadrilateral ABCD consists of exactly those two triangles, triangle ABC and triangle ADC. Okay, what we already found out that the area of triangle ABC equals to ABY over 4R and the area of triangle ADC equals to CDY over 4R. Okay, we took a common factor of y over 4R out of this expression, and we got that the area of quadrilateral ABC equals to y over 4 times AB plus CD. Then we focused on triangle BDC. This triangle, according to rule number 3, because of the fact that this triangle is inscribed by this blue circle, therefore the radius of this blue circle will be equal to the product of triangle BDC sides, that is to say it will be equal to B times C times X over 4 times the area of triangle BDC. According to rule number 3, we multiplied equation number 5 by the area of triangle BDC, and we got this equation, and then we divided equation number 5 by R, and we got that the area of triangle BDC equals to BCX over 4R. Okay, then we focused on triangle ABD. Triangle ABD is inscribed by this blue circle, therefore according to rule number 3, the radius of this blue circle will be equal to the product of triangle ABC sides, that is to say it will be equal to A times D times X over 4 times, it will be equal to A times D times X over 4 times the area of triangle ABD. We multiplied the equation number 6 by the area of triangle ABD, and we got this expression, and then we divided equation number 6 by the area of triangle ABD, and we found out that the area of triangle ABD equals to ABX over 4R, and we already found out that the area of triangle BDC equals to BCX over 4R. Okay, but we know that the area of triangle ABD plus the area of triangle BDC equals exactly to the area of quadrilateral ABCD. I will repeat again. The area of quadrilateral ABCD equals to the area of triangle BDC plus the area of triangle ABD. But we have already found out that the area of triangle BDC equals to BCX over 4R and the area of triangle ABD equals to ADX over 4R. We took a common factor of x over 4R out of this second equation, and we got that the area of quadrilateral ABCD according to the second equation equals to x over 4R times BC plus AD. And we have already found out that the area of quadrilateral ABCD equals to y over 4R times AB plus CD. So we multiplied the equation number 1 by equation number 2, and we got that the area of quadrilateral ABCD squared equals to this expression. And then we took out a root out of equation number 3, and we got that the area of quadrilateral ABCD, first of all, in the numerator we add 4R squared, and the root of 4R squared is 4R, and the root of, and we took a root out of this equation number 3, so this expression will be under the root. Okay, this expression is under the root, and the root of 4R squared is 4R. So the area of quadrilateral ABCD according to the third equation equals to this expression. We multiplied the equation number 3 by R, and we got that R times the area of quadrilateral ABCD equals to this expression. Then we divided equation number 3 by the area of quadrilateral ABCD, and we got that the radius of the square equals to this expression. Then we know that according to rule number 2 that xy equals to AC plus BD, so we can substitute xy by AC plus BD according to equation number 2. So we substituted AC, we substituted xy by AC plus BD here, and we got this expression. We found out that the radius of the square equals to this expression. Then we calculated the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to this expression to the root of s times a times s minus b times s minus b times s minus c times s minus d. S equals to a times b plus a plus b plus c plus d over 2. And we know that a equals to 3, b equals to 4, c equals to 5, and d equals to 6. Therefore, s equals to 9 units. And the area of quadrilateral ABCD equals to the root of 360. So we substituted the area of quadrilateral ABCD by the root of 360, and this is the radius of the circle. We know all the values of A equals to 3 units, B equals to 4, C equals to 5, and D equals to 6. So the only thing that is left is to put the data inside this equality. AC, for example, A equals to 3, C equals to 5, so 3 times 5 is 15. B equals to 4, D equals to 6, 4 times 6 is 24. And so on. BC, B equals to 4, C equals to 5, so 4 times 5 is 20. AD, A equals to 3, D equals to 6, so 3 times 6 is 18. And AB, A equals to 3, B equals to 4, so 3 times 4 is 12. And CD is C equals to 5, D equals to 6, so 5 times 6 is 30. 15 plus 24 is 39. 20 plus 13 is 38. And 12 plus 30 is 42. So the expression inside the root equals to 172.9. So the radius of the circle equals to either to the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. I will repeat again, the radius of this circle that blocks quadrilateral ABCD equals to either the root of 172.9 over 4 units, or in terms of numbers, the radius of this circle equals to 3.287 units. Okay, thank you very much.